All right. Hi, everyone. Thank you so much for joining in today and welcome to today's webinar, Building Heat Resilient Communities, Youth Mappers and Esri in Action. This webinar, hosted in collaboration with Esri, will walk you through how you can map extreme heat and identify cooling solutions using geospatial tools, helping to build a more heat resilient communities around the world. We are joined today by two speakers. First, Michael Gold, professor of GIS at the University Jean in Spain, and since 2009 has been the global education manager at Esri. We're also joined today by Dr. Ebenezer Boateng, or Boat, a postdoctoral research scholar at Arizona State University, the YouthMappers ArcGIS administrator, and a member of the YouthMappers Alumni Council. His work focuses on applying geospatial science to sustainable development, including environmental monitoring and conservation, public health, and climate resilience. With that, I will hand it over to Boat and Michael.
Hi, glad to have you all here. Um, we know that there are lots going on when it comes to climate-related issues, and heat has been considered as the silent killer by the World Health Organization because it leaves no traces behind as some other climate-related disaster does. And so you would be there and you would hear people passing away, and you can't really figure out what actually killed them or caused their morbidity. And so we are here to look at how we can help our communities to be more resilient when it comes to heat. So what do we know about extreme heat? Looking at the trends on your screens now, from the 1850s to 2025, there has been a consistent acceleration of the global average temperature over time. And this is coming from various sources. This is coming from the Berkeley Earth source, where they have shown that there has been a steady increase over the period. And from the 2000s, it's been increasing steadily, like increasing higher. This is also coming from the European Commission, where they have also shown that still temperatures are increasing and we need to take an action now. So whilst this has been known that, okay, temperatures are rising, we want to understand what its impacts are on human beings and the environment at large. So when we look at the effects, the World Health Organization reports that globally about 500,000 people die every year as a result of extreme heat. When it comes to wildfires and drought also, the increasing temperatures are causing about 124 million people facing food insecurity across the globe. And when it comes to economic constraints, people are unable to work during the hot periods, leading to limited labor hours, loss of productivity, and many others. Especially one of the critical resources we are also having challenge with is access to water because of the extreme heat. Some areas are having their water drying up and all that, limiting their access to water and food. And so we are here to look at some of the ways we can use geospatial technologies to build our communities to be resilient towards extreme heat. And our focus is going to be on the human side today. Maybe in a couple of times we can look at the implications on the other side as well. So I would hand over to Mike for him to give us a demonstration on using geospatial technologies for extreme heat mapping.
Excellent. Thanks, Boat. First, I should say that it's a pleasure to be collaborating again with YouthMappers, as we YouthMappers have been collaborating over the years. Remember, about 10 years ago, we did a nice training during the Phosphor-G conference in Tanzania. And lately, we've been collaborating on this interesting topic of extreme heat, extreme urban heat mostly. And one of the things that we like about this topic is that it affects people around the world. Even if you live in a not so hot place, it's affecting your crops and it's affecting tourism and many other things. And so we like, of course, utilizing geospatial technologies to be able to look at these problems. And just a reminder that what I'll be showing you in just a few minutes is a very simple vision of how to look at heat and how to look at some other attributes and some other entities within your world. Of course, there are heat specialists, such as those working at Arizona State University. And here, there's an organization called Kappa that we collaborate with, which is a consulting firm. And they go around the world, mostly in the US, but here they're in a city in India, and they do traverses. They take inexpensive sensors and put them on bicycles and cars, and they drive around various roads and they collect heat data. And then they interpolate that, they combine it with imagery, they use some machine learning. So this is just one example of what experts are doing. And so again, what I'll show you now is a kind of a quick and easy way of looking at heat. But if you want to get more specialized and more detailed and more scientific about it, of course, there are lots of options, and Boat will show you some of those examples in just a minute. See if I can get to my next window here because I've got something covering. Okay, see if I can move that. There we go. So one of the first things I'd like to show you is that there's this application called the Landsat Explorer. And the way that I'm going to look at heat is looking at land surface temperature, which is taken by the Landsat platform. And so I think you know about this. Landsat has been flying for many years now, and it has a thermal sensor or sensors on it, collecting data at approximately 100 meters and then resampled down to 30 meters. What I like about the Landsat Explorer, and this is an application that's freely accessible on the Living Atlas, which I'll show you in just a moment. What I like about it is that I can go anywhere on Earth, and I know that Boat wants to look at Gombe, Nigeria, so I'll also take a look over and zoom into Gombe and take a look here. And this gives me access to the entire archive of Landsat imagery for any place on Earth. So I can zoom into my area of interest here, and I can say I would like to find a scene. And I've got a calendar here. I can go and I can look back and I can say, looks like on August 2nd, there was a very cloudy day. So I'll try to avoid that one. On August 10th, 38% cloud cover. November 6th, 1%. So I can choose any day I want during the year, and it kind of zooms in and shows me that imagery. But more interestingly, here I have a whole bunch of renderers, or the algorithms have been pre-computed. So I can say I would like to look at surface temperature, and it gives me the surface temperature readings from that particular date. And I can go into my city of Gombe and I can click on a particular pixel, and I can get not the ambient temperature, but the surface reflective temperature. And of course, this is not what I feel when I'm walking around Gombe, but it gives me an idea. And what I like about this particular data set is I can go anywhere on Earth and I can go back 40 years to do comparative studies. So I can look at my particular city throughout time. I can compare my city to other cities, and I can get a rough idea of which time periods we had extreme heat and which parts of the city had extreme heat. Um, So sorry about that. This is the Living Atlas that I referred to. So if you search for ArcGIS Living Atlas, you will find a large collection of curated data. And this is by and large analysis ready data, ARD, including Landsat imagery. So I can go through here and I can see lots of different versions and different subsets of Landsat imagery that people have curated and have made available for me. If you're a remote sensing specialist and you want to do all the processing and the corrections, you can still do that. Here's the Landsat Explorer that I just showed you, right? So this is one of the many sort of visions you have regarding Landsat. I'm going to go in and I'm going to look at Landsat level 2 data in just a moment, and that's where I found it here. So what I do in my simple demonstration here is I jump into ArcGIS Online, and hopefully you know about ArcGIS Online. YouthMappers has an account, so if you need to get access, Boat can help you to jump in and to utilize your YouthMappers account. And what I do is I, first of all, zoom into a particular area. So in this case, I've gone to Gombe, and that's what we're looking at. But because it's global, I can zoom in anywhere, and I can then bring up various data layers. And so what I've done is I've brought up the Landsat data layer. How did I do that? I went to add, and I can search in my own content. I can search in my organization's content. I went to that Living Atlas that I just showed you a moment ago, and I searched for Landsat. And then this is a a different view of what I just showed earlier. Landsat, Landsat, lots of different Landsats, right? And I chose Landsat level 2, which is a fairly highly processed version of the Landsat archive. And this is being hosted on the Microsoft Planetary Computer. Now, this allows me to go anywhere on Earth and go to processing templates and say, okay, I would not like to look at natural color. I'd like to look at this particular part of the Earth, but I'd like to look at surface temperature pre-calculated in Celsius. And it takes me to the most recent cloud-free image of that particular part of the world. And if I click on a pixel here, I should get my information, including 49 degrees Celsius, which again is not the ambient temperature, it's the reflective temperature. It tells me that that particular date it was very hot. I can go through here and I can say that I'd like to go to the image collection explorer, and I would not like to have the most recent one. I would like to sort of go back and sort by acquisition date, most recent, and then I like to kind of scroll through here, and I like to find the image from a particular time period. It's not so easy for me to find the best image. That's when I like to go back to my Landsat Explorer and find the scene and go back to a particular date and then kind of zoom around here and find which day of that particular time period might have a better image for me to look at. But I'll just go through here and I'll guess, and I'll say I would like to look at an image from uh, 7th of June. And if I select on that, it will give me the heat information from that particular time period, right? So 42 degrees. Okay, so I can go anywhere. I can zoom in. I can check any particular date when we have a cloud-free image, and there I've got my my heat. Again, it's sort of a surrogate or a rough approximation of heat. We can see the distinctions here, which I can sort of highlight by going to properties on that layer, and I can say I would like to give it a little bit more or less transparency. So I can see the satellite image that's underneath that. Of course, within ArcGIS Online, I can change my base map, and I can say right now I'm looking at high-res imagery underneath, but I can say I would like to look at streets or topography or oceans or National Geographic. I can even look at the OpenStreetMap base map. So I'm looking at imagery, and then on top of that base imagery, I'm looking at this Landsat level 2, which is giving me an idea for a particular time period, places that are hotter than others. Um, You'll notice I've got some hospitals here. How did I get those hospitals? By going into the OpenStreetMap data, which is also hosted on the Living Atlas. So I'll just show you how I did that. I said I would like to add a layer from the Living Atlas, and I would like to look at OSM. And I know that some people have been curating specific portions of OSM. And I know there's a whole bunch of specific Africa data. So I filter on OSM Africa, and I've got highways and land use and, oh, medical facilities. I'd like that. So that's what I did. I clicked on add medical facilities. I can do that again. And it gives me a whole bunch of medical facilities, but I don't want them all. So I can go through and I can filter, and this is important, right? I would like to create a filter on my OSM data and say I would like only amenities that are hospitals, for example. So that's what I did earlier, right? Now I've got two versions of the same, but that's okay, right? So I've got my hospitals. And then what I did with regard to the hospitals that I had here on the screen was I said, I would like to calculate how many people live within a 15-minute walking distance from those hospitals. Because what we're thinking about in our particular heat scenario is perhaps the hospitals are being used as cooling centers. So I'd like to know who are the people who can walk to a cooling center in a hospital within 15 minutes. So what I did there was I went to the analysis capabilities of ArcGIS Online. And I said, I'd like to look at proximity analysis, and we have lots of possibilities. I said, I'd like to do travel areas. And I said that the input layer are my medical facilities. And I don't want driving time, I want walking time. So that's one of my options here. And I would like the cutoff of 15 minutes. So I said walking time within 15 minutes. And then I give it an output name, which I've already done. So I'll just say test here. And then before I hit the analysis button, I go to environment settings because this allows me to calculate the polygons, the walk time polygons on the full extent of all the OSM data in Africa. Nope, that's too much. I want to constrain it to the display area so that I'm only going to be analyzing these particular hospitals that are within my display. Now, I won't run that again. It'll take 3 minutes or something like that. But I've done that previously, and that's what I have here. So now I've got these walk time polygons around my hospitals. And you're starting to see how in just a very few minutes, we're able to start putting together the layer cake of our GIS analysis. And we haven't even really done much analysis, but just a visual analysis allows us to look at which are the hotter areas within the city um, that have particular population within a 15-minute walk to these cooling centers. I might also want to add some land cover because I'd like to know where the trees are. So if I go back to the Living Atlas, I know there are lots of different land cover, and there's one called, well, let me just look at land cover here. Lots of different versions of land cover from different time periods. And there's one here called World Cover. Now, World Cover gives me a global coverage. This is created by the European Space Agency. And this is going to give me my land cover. And again, I go to properties and I play around with the transparency so I can see what's underneath. And then if I turn off some of these other layers, what I might want to do is to compare my imagery base map with what I've just created here. So I've brought up the world cover, and you can see here how it aligns pretty well with tree covered areas, right? So again, in just a few minutes, I'm able to bring up a series of layers that even a simple visual analysis is going to allow me to make a few assumptions and to be able to communicate perhaps to my city management or to some researchers. I think we ought to look at a particular area of the neighborhood because here we've got a particular area where people are near or not so near to hospital facilities, lack of tree cover, high temperatures during certain time periods of the year. And I think you can imagine how this goes, right? I might also like to add data, and this is the last one that I'll do for interest of time, is I know I can also look at population estimates because the world pop data also is here in the Living Atlas. So this is from a university in the UK. I think you probably know the world pop data, 100-meter data and 1 kilometer data. And this is a raster coverage, which also gives me an idea of um, where people live. And I can overlay that and play with the transparency as well. And it gives me an estimate within each one of these 100-meter cells. And it's not perfect, but at a regional level, it's actually a quite good population estimate. And so you can see how we're able to grab this analysis ready data and start doing some really interesting, fast uh, visual analysis to be able to start thinking about our scenarios for extreme heat. Where do people live? Where's the vegetation? Where's the heat, etc. I will leave it at that for now, but hopefully you get an idea that you can do lots, including analysis with ArcGIS Online. Of course, you save that, you turn it into a story map, you turn it into a dashboard, you can do lots of things. And we would certainly encourage you to do that. When you've created something interesting, don't just sit on it as a shapefile, publish it as a feature layer, publish it on ArcGIS Online, and then other people can get access to it in the way that I've just got access to data that other people have created and have shared. So anyway, that was a quick tour. I want to give Boat plenty of time and to leave some time for questions as well. Over to you, Boat.
All right. Thank you so much, Mike. That was very insightful. And I need to say that again, as Mike said, these temperatures that we are seeing does not reflect how people feel the heat, but rather it's how the environment is portraying the heat. So therefore, we can't translate it as how people feel the heat. However, your exposure in that environment over time is what will cause serious challenges to your health over time. So I would go into a deep dive of our workflow on what has been designed that we are encouraging, or we want youth mappers to adapt and use for their chapters and also build resilient communities. So my approach will start with the ArcGIS Pro and transition also onto the ArcGIS Online for the cooling center optimization. But in the Pro, it's basically going to focus on the extreme heat mapping. So as Mike said, for the want of time and all that, we have pre-processed them, but I'll walk you through. So the first part is to get your study area, which I'm already showing here as Gombe. And then we want to go to the add data, go to the Living Atlas, and then also search for Landsat. And then we are more interested in the level 2 Landsat data, which when you load looks like this. But if you are able to see clearly from your screens, you are having some cloud cover and all that. And then because there are pre-processed data sets that we are interested in, I would want us to see how to do it. So you just go to properties, and then we are now going to scale it down to look out for the data on LST, NDVI, and NDMI, which is the normalized difference moisture index. So in your properties, you just need to come to the processing template, specifying which data that you would want to use. So in here, we would be interested in using the surface temperature in Celsius for analysis. The next thing is to go through the mosaic process. And in the mosaic process, you are going to have a ton of data sets available to you. So how do you want to operate with this data? In here, we just want to initiate one for the start, you would usually pick the first. However, we are interested in the mean so that it would collect all data sets within your area and then try to create an average for it. So we'll choose the mean, and then we come to the definition query. This is quite important where you want to get the quality data and not just anything. So you set the parameters ensuring that your cloud cover is less than 30%, which in here we translate as 0.3. And then you also indicate the summer periods. You can decide to consider all months around the year, but in our workflow, we are concentrated on the summer periods, which are within the months of June, July, and August. Some people experience even some of their summer periods in September, so you can decide to add it. But for the demonstration purpose alone, we are focusing on these 3 months. Once you are done, you click on OK. The system processes the data for a while, and then you would have the data provided for you. Once the image renders, it would look like this. Please don't get scared. You've not lost the data. It's actually how it's displayed, but when you go through the process of clipping using the clip raster tool, you will be able to clip it and then get an image like this. So this is how when you clip, you get it. Now, interestingly, we have temperatures within 31 degrees Celsius to 42. Again, I would reiterate that this is not how the body feels. This is the environmental capture of the temperature. And so continuous exposure would rather put you at risk, but does not mean how you feel. Now, I need to make you understand that there are a ton of data sets that have been put together. So we repeat the same process where you come to that data set again, you go to properties, and then you now don't change anything about the mosaic and then the definition query. It's just the processing template that you are now coming to switch. And so you have the NDVI for analysis. So you just select this and then you click on OK. once it also renders, you can clip it and then get your output as we have it here. So you now things have become much more easy. I remember those days when we started GIS, you needed to pick the data, download them, and then process them. But now having all of them in one place, in one layer, and you just need to understand the extraction techniques to be able to do this is interesting and quite helpful when it comes to helping your communities become resilient. And so we use the same process to extract the normalized difference, um, moisture index. And we now go through the next step where we are going to reclassify this data set. We are trying to integrate all of these together to create a heat severity or a heat stress index. So we are going to use just these three variables. However, you have the opportunity to add as many variables as they make meaning to your area. But for the demonstration purpose, we are just focusing on these three. So the first thing we want to do is to go through reclassify, and then we try to reclassify these to make sure they are all having the same standardization, where standardization means you are trying to let the system understand that, okay, when I see one across these images, this is what it means. When I see two, when I see five, this is what it means. So we put in the LST data here, we classify. Now in here, you can decide to create your own classification, but for the purpose of demonstration using the Jenks classification system, we are going to have the values being kept like this and run the analysis to get this, which we have here. Now, the NDVI and then the NDMI have an inverse relationship with LST. What this means is that areas where there's high LST, there is low NDVI, and there is also low NDMI. So when creating the reclassification, you need to reverse your scale for it. So for instance, if I bring in the NDVI values, I need to reverse the classification. So where there are low NDVI will now be 5, 4, 3, 2, and 1. The reason being that whilst we were classifying the LST, we made sure that 5 means high and then 1 means low. So when it comes to the relationship these other two variables have with LST, it's inverse. So we need to reverse the process. That is what we do here. So after reclassifying all this, we use the weighted overlay analysis tool to bring them together to create the heat stress index. So in here, once we bring it in, we just click on the reclassified tools and then also assign appropriate proportions to it. Some of these things, you can see them in the literature, existing literature, but for the purpose of demonstration, we are assigning 25, 25 for this and then giving LST 50 because it's the main contributor to extreme heat. Afterwards, you give it a name and then run. Once we run, we get this output, which gives us an idea of areas where there are extreme heat or liable to extreme heat. For the next level, we were interested in picking the top 3 areas, which is the 3 to 5, where the people or the environment looks very warm, regardless of putting all these things together. And after that, so to do that, we just have to also go to the reclassify tool. In the reclassify tool, we bring in the heat severity image again and reclassify such that the top 3 would be in the same class. So we have 1 being 1, 2 being 1, and then these ones being 2. Just to make sure that we have them being same. Now, based on that, we were able to come up with this. The purpose of doing this is make sure our interventions are targeting the right places, since we all understand the cost of limited resources in our area. You can decide to do for the entire area, but then you get to realize that some areas may not really need it as urgent as others. And so the need for you to restrict or bring it down to much more targeted areas for effective implementation. So we do this, we are able to find this. Now, I also went through a different approach where I used the hot export tool to extract this data from OpenStreetMap. So in doing that, there's a manual in the chat where you would see the workflow for how the export was done from hot. We have all these data sets here. So the next thing I had to do was and you have them in polygons, and it's over 100,000. So what I did was to reduce it, one, by converting to points, and then also ensuring that they are points within the place of interest. So these are the points that I have here. Now, in the ArcGIS processing tool, we have the random selection tool, which was used to select 1,000 buildings for the purpose of modeling. The more buildings you have, you would have to pay more credit when it comes to the cooling center optimization. But because you are trying to create this model for intervention purpose, you may not have to necessarily use all of the buildings. And so you use this random sampling approach, give it a fixed number, which I targeted 1,000 building, 1,000 buildings, and then you give it an output. After doing that, these are the buildings that were extracted, and I made sure they were within the areas we are interested in, the areas we are considering having high temperatures. And so we have these buildings here, and then we also have the health facilities here. Let me change the symbology to make it a bit clearer. So we have these health facilities here, which we are thinking could be places where people can seek help when they are extremely, or when they experience heat exposure, or when they need a place to take shelter when we are in the extreme heat periods. And so this is how we extract the data, or we go to the workflow to make sure we have all the data ready for the solution. Because for us, we are not just interested in mapping the heat. And so what happens next? Providing solutions is what matters to us the most. And so we now take the data from here, especially the buildings, the random buildings we've extracted, and the health facilities. We take it to the ArcGIS Online. So in ArcGIS Online, now this part would look similar to Mike's own, but it's just that there will be a slight change. And this also draws our attention to there's no one way in doing things in GIS. There are multiple ways in doing things. So in here, we have the health facilities being the blue, and then the orange symbols here being the buildings. And so the next thing that we have to do is to go to our analysis tab. And in our analysis tab, we go to the tools and then find locations. So in find locations, we choose best facilities. And with the best facilities, we are also going to focus on using the allocate existing facilities to a particular, so allocate to existing facilities. The purpose is that we are trying to see how we can let's imagine that all these health facilities are accepting people who are exposed to heat and trying to give them some form of assistance. We are trying to see where can people go to in this scenario. So here we also change it from drive time to walk time, and then also specify that we are looking at demand locations to facilities, and our demand locations are the buildings. The assumption also here is that people are going to move from their homes where they have limited air conditioning, even some places not having electricity, but still they need to survive. So how can they move from their homes to these facilities? And so we do that. So it's now going to, the travel direction will be from the demand point to the facilities. Then for the demand locations, we are going to make sure we select the buildings, which is the random buildings we already selected earlier. And then the facilities would be the health facilities that we have here. The next thing to do is to give it a name where we will say maybe test. And then we also estimate the credit before you can run. And so this is what would happen now. The final results would look like this. And we find it interesting that out of the 23 health facilities within the area, two of them were considered not ideal places for people to visit, and some other places were assigned buildings. So you see the red areas here, they were deemed not eligible for people to use. Now, this gives you an idea, especially if you are working with other stakeholders, to let you understand that, okay, when it comes to designating areas for cooling centers, these areas can be considered. This one would all need not to be considered. And this is how far people can walk averagely to such places. So this is one approach where we can use to help make our communities resilient. Imagine making such a map, presenting to your local people or people within your communities to create the awareness that when these implementations are done, this is the place where you can seek shelter when there's extreme heat and all that. So this is a quick demo. We have a drafted workflow already, which is in the chat. You can pick that and also follow this workflow to also conduct a similar analysis for your community. Thank you so much. And we would now open the floor for question and answers. But before we do that, we had 3 people in West Africa who have been working on extreme heat over the period. One is Adamu, who we collaborated with, including YouthMappers in Nigeria, to map health facilities and also look at their access to the grid or access to electricity, because the idea is to make sure that apart from mapping the polygons using the remote mapping approach, get field data, more attribute data to help us in coming up with realistic solutions to some of these problems. So in Nigeria, Gombe, this is a similar project we did, and Adamu was part of the project. There are other projects in Sierra Leone and Freetown where people were mapping extreme heat. For instance, in Freetown, their focus was in urban slums, looking at how to find solutions to extreme heat in urban slums. The Sierra Leone project is underway, and they are also mapping extreme heat and trying to find solutions to this. So I now open the floor to questions if you have any.
Don't be shy. We know people always have questions and comments. While people are thinking, let me just underscore what Boat just said regarding attributes in terms of data quality. We have some really interesting data sets that we make use of, and oftentimes they're lacking some of the interesting attributes that we need. You mentioned buildings, for example. You showed that you extracted or you used a building extraction data set. Oftentimes, those buildings don't tell us what the purpose of the building is. We don't know if it's an apartment building or a garage or an office building. If we knew the category of building, we could estimate population, and that would be fantastic. So just a reminder that when you're collecting data, do add extra attributes and metadata as well, because it helps humans, but it also helps AI when AI is using your data to help us to solve problems.
I think there's a hand up. Yeah, Abla.
Hello, thank you so much for the presentation. It was really interesting work. I have just a question or a little bit of curiosity. I was wondering, the main challenge, for example, for global south and developing countries is the software access. Like, for example, these methodologies from ArcGIS, and I was wondering that if there is a methodology you have done with QGIS that is an open source, if it's possible.
Yeah, I would respond to this, and I don't know if Mike can add up a bit. So one, if you are a youth mapper and you are using it at your community level, thanks to Esri, we have some limited licenses available where we can share with you to continue with your project. The next thing is that although this methodology is designed in relation to Esri product, it is easy and transferable to QGIS. The only limitation here is the use of the ArcGIS Online. But if you have a bit of understanding in network analysis, you would be able to do the cooling center optimization on that regard. So that is what I would say, because you can still model LST and NDVI using Google Earth Engine, bring them down into QGIS, try to do your multi-criteria analysis, and then put the much more higher heat stress index areas. Make your selection of the buildings and the health facilities or other areas. Some people can use malls, some people can use churches as cooling centers. Do all that. Then if you have a bit of a background in network analysis, just do some of these routing options, and then you'll be able to come up with the final output. So it's not just restricted to Esri, but then this was tailored towards Esri's approach.
Yeah, Esri considers that the integration is one of the big strong points of the ArcGIS platform, right? The pieces fit together and the data is ready to go, and you don't have to do so much fiddling and programming. But some people like to do that, so it's up to you.
Yeah, so whilst we are waiting for questions, Mike was talking about the attribute data part, and then I know for us within the OpenStreetMap space, we continue to use apps like OSM and Mapillary. I want you to continue gathering some of these data so that there will be enough data for being specific on some of the analysis. For example, if within your community you're able to tell which of the buildings are residential areas, that would help us know that, okay, now when we are filtering out, we are going to focus on buildings just meant for residential areas. Then the next level is trying to also, that would also help us in getting population data to even understand, create a dashboard to know people who are likely going to be affected and all that. So gathering more attribute data is quite important for us now. And then through the advancement of technology, now more buildings have been mapped through AI. And RAP ID is one of the platforms where now we are encouraging people to use to continue mapping. So they already have AI extracted buildings and you need to validate it. So as youth mappers or people from the open mapping community, we are encouraged to now provide more attribute data that would help us make realistic estimations or projects that can transform lives. So that is my take on contributing more in terms of attribute data in this age. Any other question? Do we have concerns? I think in the chat, someone is asking that, can you review the credit usage when using these tools? Mike, would you want to respond to that?
Yes, and so one example is that when I decided to process the walk times from the hospitals, before I hit the go button to do the processing, I checked to make sure that I was only analyzing my particular window of interest. And there's a little button where you can estimate the credits. And so doing so only, consumes maybe a credit or something like that. I noticed that when Boat did his example, he didn't hit the processing, but just before he was about to hit it, it said 100 credits. That's probably because he did not constrain it to the particular window of interest. And so, yes, there's a way that you can estimate the credits, and you can decide, just like you decide with your own computing resources, whether it's worthwhile running the process or not. See, Patricia has her hands up.
Yeah.
Hi there. I wanted to say thank you tremendously for Dr. Gould for not only your partnership with Esri, but also just the presentation today, and also Dr. Boateng for a tremendous amount of work in putting the materials together. I also wanted to say that this is a true YouthMappers collaboration, because I know this represents a lot of work with about 8 or 9 different YouthMappers chapters in Nigeria, actually, where some of the data that was collected in OSM that was pulled into this presentation actually was a local collaboration. So I wanted to give a shout out to that, because YouthMappers open mapping is a team sport, as we all know.
Mhm.
And then I see some of the comments in here. You all know as well, this represents just one tiny sliver of the way that we all work. This kind of information really relies heavily on local knowledge. And I really want to call a shout out to a couple of the pieces of information about the fact that someone, well, Amalola mentioned that this happens to be data during the local rainy season. Very good observation, because we have to understand what our local communities are going through. So while this is, one flow, please make sure you are with your local communities and you are understanding what kinds of data you need and adapt this to your local circumstances. I think this is really kind of an important kind of concept. And also, while there's a really strong depth of information from different kinds of expertise and different kinds of heat science, there's also the local information that you all have, students as well, because this is the places that you live. One of the questions too is, why are we thinking about the POIs, churches and hospitals as used as cooling points and not just clinics? Those are places that people also gather during emergencies, or that they can come in case, for example, people need help and their homes are perhaps not staying cool, or maybe they need to come in what we call resilience hubs. Those are common especially if there is a heat wave. They are places where people can come and get water distribution or other kinds of assistance, or especially if heat is also a contributing factor, like an additional threat. So those are common points of intersection. And sometimes they might even have cooling features, electricity, where other homes might not have it. So those are good staging centers for heat relief. So that's why they are listed on there.
Okay. Thank you. So we have one of our YouthMappers members who worked on the project, Tommy, and would want to share what he did at his chapter with us. So Tommy, you can unmute and share your perspective with us.
Hello, everyone. Am I audible enough?
Yeah.
Okay, thank you. My name is Tommy Charles. I happen to be a YouthMappers alumni and also currently working as the national coordinator for Maps. So over the years, we've been trying to develop a methodology to address heat in Freetown, specifically within informal communities. So sometime last year, together with my team at YouthMappers Sierra Leone and other YouthMappers alumni, we participated in a heat solution competition that was organized by the Freetown City Council. And fortunately, our idea was selected as the best idea to address heat in Freetown. So the idea was basically about the use of drone and satellite images and environmental monitoring equipment in order to address heat. So we infuse drone data, satellite imagery, then environmental parameters such as temperature, in addition to open mapping and data such as the OpenStreetMap platform to understand the variation of heat within informal settlements. So from that workflow, we were able to firstly determine where it was more prevalent within informal settlements and what could be done. This was in consensus with other participants or other institutions that work towards the address of heat. So we tried to earmark where heat was prevalent, where it was less, and what are the things or infrastructures that were in place that were precipitating the high amounts of heat in some locations and low amounts of heat in others. So after that, we upscaled into a project that has just kickstarted last 2 weeks ago, which is basically catalyzing data-driven to address heat resilience. So we'll be using thermal drones to capture aerial images and also temperature sensitivity data using thermal drones, and then try to understand how these informal settlements are being affected by heat waves. So we'll be taking three intervals in the morning around 5 a.m., the afternoon 12, and then at night 8, collecting drone images for those intervals so we can get a clear understanding about heat waves before sunrise, during peak hours, and then sunset, just after sunset, so we can get an understanding of what people experience during those time as it relates to heat. So we'll be working directly with community pilots, and some of them are going to be YouthMappers and also members of the OpenStreetMap community, and also residents of informal settlements. So the methodology is not so clear as it stands because we are thinking of also probably infusing the data that we'll be collecting with indoor temperature readings. So we're working towards that also. But everything that we'll be doing, all the methodologies that we'll be using throughout the work are going to be made public for everyone to learn and also replicate within their communities. So I hope to be updating everyone here. You can check me on LinkedIn at Tom Charles or check the humanitarian OpenStreetMap handles and also OpenStreetMap Sierra Leone handles to keep updated about this initiative. Thank you.
Thank you, Tommy. So do we have some more questions before we have our takeaways?
I see, Boat, you answered the question regarding the validating the AI mapped buildings, right? And you said it's using Rapid.
Rapid, yeah.
Is there a particular building data set you recommend? I know that Microsoft has a giant data set with millions of buildings.
So with RapID, they are also taking from Microsoft's building extracted and allowing OpenStreetMap contributors to really look at it. Is it because it's AI extracted, they want human beings to validate it and then also make sure that they are really well mapped out. So when you, okay, Patricia.
Yeah, and Mike, sometimes it draws from Esri world imagery as well to extract that.
Mm-hmm. Okay, good.
Yeah, Eric, can you unmute and ask your question?
Yeah, thank you so much, Watson, for the presentation. I want to ask, OpenStreetMap is constantly updated. So one of the conversation I have with some project I was doing geospatial was last updated around 2015 or so, which means that if I stand to be corrected on that date, but what it means is that maybe current features, it might be difficult for us to capture those features when we are using the OpenStreetMap. So I don't know if you took that into consideration, or you have the current updates version that gives you the current features or attributes
Yeah,
for the study.
sure. Thank you. So that's why in my workflow I explained that I extracted the data from the hot export tool. That gives you some kind of a live updated data. I'm not sure of the lag between when you contribute and when it reflects in the system over there, but it's quite recent. And so using the hot export tool gives you much recent data mapped into OpenStreetMap.
Thank you so much.
You're welcome.
Yeah, I would just add that if you take a look at the OpenStreetMap data that we've utilized, and if you follow more or less the workflow that we've shown, you can bring in particular subsets of OSM data. If you click on the OSM data within ArcGIS Online, it will take you, or it'll give you an option to go to the OSM database and take a look at the actual OSM data. In theory, if you see something wrong, you can edit it within OSM and come right back in and see it updated within ArcGIS Online. So you've got that two-way connection if you'd like.
Thank you so much.
But that's a good question. You always need to check for the currency of data, the completeness of data, how well is it documented, etc. Sometimes we make the mistake of finding data and thinking that our job is done, and it's not always the right data that we find. Sometimes we need to start and clean data or recreate data in order to have an effective project.
Well, with that, I'd like to say a big thank you once again to Esri, to Mike Gould, and to Ebenezer Boateng, Dr. Boat, our postdoc with here at ASU with YouthMappers. And thank you to Elodie for moderating, and to every one of you for joining us today. This is going to be posted on our YouTube channel, and you've got the resources. This is just the beginning. Thank you all for joining us, and happy mapping. Thank you so much.